Integration can also be called anti-differentiation. Let's say we have x squared for y. We know that when we differentiate this, it will give us 2x. Integration is the inverse process of differentiation. So the notation for this, to integrate it, is shown like this. Always remember to put dx when you're integrating. So when you integrate it, you do the inverse function of differentiating. So that means that this must equal x squared. We also need to add a c, which stands for the constant. A more easier way is shown by doing this. So we want to know what happens when we integrate this, what comes out. So we add 1 to the x, the n, the power, and then we differentiate, which would mean that it's xn minus 1, and this shows that it's xn, which is the exact same as here. But we want the whole equation to be this. So the a is missing. That's why we times this by a to give the exact answer here. And then we transfer this a onto here, which then, when we integrate this, would mean it's axn plus 1 plus c. Never forget the c, of course. To use this in an example, let's take 2x cubed and integrate it. So we take the x and we add 1 to the n, so that will be 4. Then we differentiate it for x cubed. But, so we have this, but the 4 is not the same as 2. So we have to make this number equal to 2, which is 2 over 4, or a half. And then we put that in here. That shows us 2x cubed plus c. That's all you have to do. This can also be written as dx. By using the simple formula, we can do this part first. So let's call that number 1. So we add 1 to 1/3, which is 4/3, and we integrate it, we differentiate it, sorry, which gives us 4. But now we have to make this equal to 2. So what we do, we times it by 3 over 2, which gives us 2, and this comes over here, 3 over 2. Now we have this. Let's call that 2. Same process, add 1 to the minus a half, which is x a half. Differentiate it, which is a half x minus a half. And to make it equal to 6, or minus 6, we do it times it by minus 12. It's 12. So we've got this and this. So we have 3 over 2 x to the power of 4 over 3 minus, because of the minus here, 12x to the power of a half plus c. Always put the c. Sometimes questions ask us, what is c? C can be found when the values of y and x are given to you. So let's put this in an example. This question is going to ask us 4 minus 6x integrated when y equals 5 and x equals 1. So let's integrate it. So we just substitute y for 5 and x 1 equals 4, 1 plus c, which gets us 4. Found 4, and now we just have to put it back into the equation. Y or x plus 4. That's it. Sometimes questions will ask us to find the area on the curve. So let's say we have this curve, and they want us to find the area underneath. These 2 points are labeled as A and B, and from this, the simple formula can be formulated as B, A, Y, X. Sometimes they would ask us to find the area under the curve like this. So what is the area? First, we need to integrate it. We know that this is B, and this is A, so we can put that in, 2 and 0. First. So we know that we've got this, and the upper and lower range is 2 and 0. The c cancels out, so basically what we do is we substitute the 2 and the 0 into x, such as this. That is the area. You can also find the area under a curve by using your GDC. For TI-84, you just go onto Math and type 9, which gives you FN int, which stands for integration, and this will come out. Basically what we have here is the upper and lower number of like the x value. So in this case, from the example used before, we'll just use 2 and 0. And the equation is y, where y was x squared minus 2x. And this is always in respect to x. So you just type x, and this will give you the same answer. We had the answer before, 4, 3, so let's test that. To find the volume of this equation, we do this. We need to integrate this. We basically do the same thing that we did for area under the curve. That gives us 348 over 5 minus 0. And basically what we've got here then is 348 over 5. We already know this part, which is And that is basically how you do it.